Is that? Hello viewers, you are welcome back. Today we are going to consider fluids and pressure in physics. So fluids and pressure. Okay, now when we talk about fluids, how do you understand by the term fluids? Okay, now basically, or to a layman's understanding, we will say fluids refers to liquids or what? Gases, right? So liquids and what? And gases. So this is what we know as what? Fluids. But now, as a physics student, you cannot explain fluids this way. So this is just a layman's understanding. Now when we say fluids, fluid is any material which has the capacity or the ability to flow. You understand? For example, water bodies, you see they flow from one point to another. As well as gases, they also flow. As a result of that, they are all what? Fluid. So fluid is a material that has the ability or the capability to what? To flow. In other words, fluid is any material that can be deformed continuously under the application of a type of force called shear force or tangential force. That's also another way of defining what? Fluids as a science student. Do you get it that way? Okay, now, so that is fluids for you. Now let's consider pressure. Now, one of the mistakes we've been doing is, when we talk about pressure, you have to take note that pressure is only affiliated to fluids alone. That's pressure. So, fluids alone. Fluids alone. That's where what pressure comes in. Pressure. And let's talk about solids. Now, the pressure in solids, we don't call it pressure. So that's the mistake students will be doing always. So the pressure in solids is known as solids, but it is known as what we call stress. I hope you now know the difference between pressure and stress, though they are the same. You understand? They have the same units of measurement and what have you. They have the same formula, but you have to use the right terminology in the area of study. So pressure is related to what? Fluids only, whereas stress is related to what? To solids. So please take note of that. That is stress. Stress related to what? To solids. I hope you now know the difference now. And now let's look at the formula or the expression for stress. So, know that stress can be expressed as force over the surface area. So, in short, force over area will give you what? Will give you stress or pressure. Do you get it that way? And now the SI unit for stress or pressure is Pascal. Is Pascal, which is P small a. You understand that? And note this. 1 Pascal is equal to 1 Newton per meter squared. Why are we saying that? You know that force is measured in newtons, right? So force is newtons, whereas area is also measured in what? In meter squared. Are you okay? Or centimeter squared. So m squared. And this is the same as n meter That's Newton per meter square. So if they are the same. So this is the unit of measurement of either stress or pressure. And now in medicine, the unit for pressure differs. Do you understand that way? So in medicine, pressure is measured in millimeters of mercury. So we have this millimeters of mercury. Please take note. Small letter M, and capital letter H, and small letter G. Do you understand it that way? Yeah. So now let's talk about the types of pressure. Types of pressure. Types. The types of pressure. Now, basically, there are two main types of pressure. We have the gauge pressure and we have the total pressure or the absolute pressure. I'm taking it again. There are two basic types of pressure. We have the absolute pressure and we have the gauge pressure. And the absolute pressure is the same as what you call the total pressure. So we have the gauge pressure and we have the absolute. We have the absolute pressure, which is also known as what? The total pressure. Yes. Now, what do we mean by the term gauge pressure? Now, gauge pressure, listen, gauge pressure is the pressure measured relative to the atmospheric pressure. The pressure measured relative to atmospheric pressure. So, this is related to what the atmospheric pressure. Whereas the absolute or the total pressure is the pressure measured relative to a perfect vacuum. It is the pressure measured relative to a perfect vacuum. Take note, the vacuum should be perfect. So this one is what a perfect vacuum. So these are the two main types of pressure. And we are going to understand the concept more when we dive into the calculation or the applications of these types of pressure. That's why we are going to understand the concept. Do you understand? So for now, just take it that way. You get to understand it as we grow. For the sake of our calculation purposes, we need to know a little bit of conventions over here. Now, we know that 1 Pascal is equal to 1 Newton per meter squared, right? Very good. And now, 760 millimeters of mercury this way. Please, it's in Pascal. It's equal to 101. That's 101,325 Pascal. Please take note of this conversion. And this is the same as 76 centimeters of mercury is equal to 101,325 Pascal. Note this. This is very, very important. Okay. So, my viewers, I would like to end here. We will continue later. See you next time. Bye-bye.